Hello everyone, welcome once again to this online chemistry class for standard 10. Today we are going to continue with the chapter that is chapter number 4, carbon and its compounds. As told by me earlier, I have posted the deleted portion for you all. This is from the chapter metals and non-metals. And now, as we are dealing with this chapter, carbon and its compounds, these are the topics that are deleted. Nomenclature of carbon compounds containing functional groups like halogens, alcohol, ketones, aldehydes, alkanes, and alkynes. Difference between saturated hydrocarbons and unsaturated hydrocarbons. Chemical properties of carbon compounds. These reactions like combustion, oxidation, addition, and substitution reaction. Then ethanol and ethanoic acid, only the properties and uses are deleted, whereas you have to learn the reactions. Okay. Then soaps and detergents. Now this slide shows the page numbers that are deleted and the page numbers that you have to read. So on the left side we have given the deleted part as mentioned in your syllabus, and then on the right side in blue color and red color we have mentioned the pages that are deleted and the page numbers that you have to focus on. Okay, so in today's session I'll be talking about homologous series, and then we will study the reaction of ethanol and ethanoic acid. Okay, now start with the definition for homologous series. See, this homologous series is a sequence of compounds with the same functional group and similar chemical properties in which the members of the series can be branched or unbranched or differ by CH2. Now we are going to focus on these points like they are the sequence of compounds having the same functional group and the members of the series differ by CH2. These points we will focus on. So what is homologous series? It's a sequence of compounds with the same functional group having similar chemical properties, and the members of the series can be branched, unbranched, or they'll differ by CH2. We'll learn these points in detail now. How? Let's take the example of a set of hydrocarbons, that is methane, ethane, propane, and butane. We'll take for example. What did we learn here? Points on which we had to focus on is they have the same functional group, they differ by CH2. These two things we have learned. How? I'll explain you. See, what will happen if I add molecular formula CH2 to the hydrocarbon seen here? For example, if I take methane, whose molecular formula is CH4, and I add CH2 to this, I get C2H6. So what is C2H6? It is ethane. So by adding CH2 to methane, I get ethane. Now when I add CH2 to this ethane, I get C3H8, which is your propane, plus CH2 to ethane. Now when I add a CH2 to propane, I get butane. Understood? So these compounds are occurring in series or not? See here, by adding CH2 to each of these hydrocarbons, when I add CH2 to CH4, I get C2H6. By adding CH2 to the C2H6, I get C3H8. By adding CH2 to C3H8, I get C4H10. Now these compounds are in series, right? Look at their molecular formula. Okay, they are in series and they are in succession also. These compounds are in series and they are in succession. Clear to you? Coming one after the other. Okay, now can you identify the common functional groups seen in them? I have told you earlier itself, when they are ending with letters A and E, they belong to the functional group of alkanes. So all these hydrocarbons which are seen here have the same functional group, alkanes, right? That means these compounds will have same general formula. So what is this general formula for alkanes? It is CnH2n plus 2. In the place of N, if you substitute 2, I get C2H6. What is that? Ethane. So when I substitute that N by 3, I get propane. When I substitute that N by 4, I get butane. So these alkanes, they all belong to the, like these methane, ethane, propane, butane, they belong to the functional group of alkanes. Their molecular formula is different, but their general formula remains the same. So the general formula for alkane is CnH2n plus 2. Remember, these compounds are occurring in series and they are in succession. They all belong to the same functional group of alkanes and their general formula is CnH2n plus 2. Similarly, alkenes will have the general formula CnH2n. This is the general formula for alkenes. Okay, but the molecular formula keeps changing. Look at the molecular formula: CH4, C2H6, C3H8, C4H10 of alkanes, right? The molecular formula is different, but the general formula for alkane is CnH2n plus 2. And they differ by CH2. By adding CH2 to every hydrocarbon, I get the next hydrocarbon. So they are all differing by CH2. So we can define homologous series as a series in which the compounds have the same general formula but different molecular formula which are occurring in immediate succession. Clear? Understood the definition? Okay. Now, see, these hydrocarbons, which are belonging to the group of alkanes, that is this methane, ethane, propane and butane, will have different chains of carbon atoms. See, methane is having 1 carbon atom, ethane is having 2 carbon atoms, propane is having 3 carbon atoms. So they will have different chains of carbon atoms but will have the same functional group and they will occur in succession. Okay, and they all differ by CH2. Now, see, these hydrocarbons have similar chemical properties. The chemical properties will not differ because they are all belonging to the same functional group. But their physical properties like melting point, boiling point, solubility will show some variation as you go higher in the series. Why? Why the physical properties are changing? Because there is a change in the molecular mass. Suppose, for example, a compound, a carbon compound with 10 carbon atoms will have a higher boiling point when compared with a compound having 3 carbon atoms. So you will find a variation in their physical properties, but their chemical properties remain the same. Clear? So homologous series are nothing but a series in which the compounds have the same general formula but different molecular formula which occur in immediate succession. Clear to you? You have to learn only the reactions of ethanol and ethanoic acid. You have to know the molecular formula for ethanol. You don't have to focus on the properties, uses of ethanol and ethanoic acid. You have to study only the reactions of ethanol and ethanoic acid. So the molecular formula for ethanol is CH3CH2OH and the structure of ethanol is given here. Ethanol is an alcohol. Now, reactions of ethanol. Ethanol reacts with sodium to give you sodium ethoxide and it liberates hydrogen gas. Since hydrogen is separated out here, it's an example of a displacement reaction. So, when sodium reacts with ethanol, that is CH3CH2OH, it forms sodium ethoxide, CH3CH2ONA, and it liberates hydrogen gas. So, reaction of ethanol means ethanol reacts with sodium to give you sodium ethoxide, and it liberates hydrogen gas, and it is a displacement reaction. You have to know the formula for sodium ethoxide and ethanol even. Now, reaction to give unsaturated hydrocarbon. Now, when ethanol is heated at 443 Kelvin with excess of concentrated sulfuric acid, it results in the dehydration of ethanol. Dehydration of ethanol means what? The water content will be removed and it leads to the formation of ethene. Okay, so here how does it happen? Now this concentrated sulfuric acid acts as a dehydrating agent, and this removes one hydrogen atom from this CH3 and this OH. So H2O is getting removed, which leads to the formation of unsaturated hydrocarbon, that is your ethene, right? So on heating ethanol at 443 Kelvin with excess of concentrated sulfuric acid results in the dehydration of ethanol, means what? The water content from the alcohol is removed and it leads to the formation of unsaturated compound, that is ethene. Here what is acting as a dehydrating agent? Your sulfuric acid is acting as a dehydrating agent, and it removes one hydrogen atom from this CH3 and this hydroxide, that is OH, okay, from ethanol. So water is completely removed and unsaturated hydrocarbon, that is your ethene, is formed. Clear to you? Coming to reactions of ethanoic acid, again I'm telling you, don't have to study the properties and uses of ethanoic acid. You just have to focus on the reaction of ethanoic acid, like esterification, saponification, and reaction of ethanoic acid with a base, and how does ethanoic acid react with carbonates and hydrogen carbonates. Only those things. Since you are going to write the equations, you should know the formula for ethanoic acid, that is nothing but your CH3COOH. Okay, and the common name for ethanoic acid is acetic acid. So this ethanoic acid is formed when ethanol is oxidized with mild amount of oxygen. You have to just focus on these things, that is esterification reaction. Esterification reaction is the reaction in which the ethanoic acid reacts with ethanol in the presence of an acid, and this acid acts as a catalyst leading to the formation of esters. Esters are nothing but sweet smelling substances which are used in making perfumes and also used as flavoring agents. So these esters are formed when ethanoic acid reacts with absolute ethanol in the presence of acid as a catalyst. You know what is a catalyst. Okay, now this esterification reaction, ethanoic acid, that is CH3COOH, reacts with CH3COH2OH, that is your ethanol, leading to the formation of ethyl ethanoate. What is that ethyl ethanoate? It is nothing but your ester. Okay, CH3COOCH2CH3, and water is also formed. So ethyl ethanoate is a chemical name for ester, and ester is formed when ethyl alcohol reacts with ethanol in the presence of acid as a catalyst. Okay, next, saponification. This is normally used in the preparation of soaps. Now this saponification reaction takes place when this esters are treated with the base. Okay, when these esters formula is given here, CH3COOC2H5, when this is treated with a base like sodium hydroxide, it leads to the formation of alcohol, and then it forms a salt of carboxylic acid, sodium salt of carboxylic acid, and this process or this reaction is known as saponification. So here the formula for ester is given here, CH3COOC2H5. When it is treated with a base, that is sodium hydroxide, it leads to the formation of a sodium salt of carboxylic acid, that is CH3COONA, okay, along with alcohol, that is your C2H5OH. What is C2H5OH? It is nothing but your ethanol, correct? C2H5OH. Clear? this ethanoic acid reacts with the base. So normally an acid and a base, when they react with each other, it leads to the formation of salt and water. So here ethanoic acid, it reacts with the base, that is sodium hydroxide, to give you sodium ethanoate, which is nothing but your sodium acetate, commonly known as sodium acetate, and water. So it's an example of neutralization reaction. Now, reaction of ethanoic acid with carbonates and hydrogen carbonates. When this ethanoic acid reacts with carbonates and hydrogen carbonates, it leads to the formation of a salt, and carbon dioxide and water is formed as a product. And the salt produces commonly known as your sodium acetate, that is CH3COO So when ethanoic acid reacts with carbonates and hydrogen carbonates, it leads to the formation of salt, liberates carbon dioxide gas, and forms water. So here in the case of this ethanoic acid, it reacts with sodium carbonate to produce sodium acetate, carbon dioxide, and water. Similarly, this ethanoic acid reacts with sodium bicarbonate or sodium hydrogen carbonate to form sodium acetate, and then liberates carbon dioxide gas, and water is also formed. So with this, we are coming to an end of this lesson. So in this video, I have explained clearly the topics included from this lesson. What are the things you have to focus on? Whatever things taught apart from the deleted portion is to make you understand the basics. Okay, so all the best to you all. Start studying, start preparing for your board exams, and take care of your health. Have a good day. Bye.